Okay, we're talking over that final review packet again. And on number 9, it's a nice one because the bases are already the same. So that just means this has to equal this. Super easy equation. You solve it and you got it. This one, though, the bases aren't the same. But you can make them the same. But a lot of people are like, so how the heck do you do that? Is 9 to the what is 27? You don't want to do that. You don't want to try to make 27 into a 9. You want to make the 27 into a what? A 3. You know why? Because this 9 can also be made into a 3. So think that through for a second. Do you get we can make this into a 3? I mean, 9 isn't 3, but it's 3 squared. And 27 isn't 3, but it's 3 to the third. Do you get then that when you rewrite this, the bases will be the same? 3 to the second to the 2x minus 5. 3 to the third. Okay.
Could you also just make that 27
9 to the 3 isn't 27. If it was, it'd be great. 9 times 9 times 9? You were thinking of 9 plus 9 plus 9, weren't you? Okay, so it's not 9 to the third. It's 3 to the third, though. Okay, so why did we do all that work? So that these would be the same. So now that equals this. But a lot of people are going to go 4x minus 5 equals 3. Wrong. Why isn't it 4x minus 5? Yeah, so this is 4x, but it's 4x. Well, distribute that 2 out, and you get 4x what? Minus 10. Okay, so there's some help on number 10. Number 11. Do you remember how to fix a 2/3 power? Yes, you flip it. Times by 3 over 2. But remember, I'm putting it to a power. So this 9 is to the power of 3 over 2. Now, you will have a calculator on this test. So I'm not scared of this. I mean, they just cancel. But what I'm scared of is, will you know how to do 9 to the 3/2 power on a calculator? Everybody use whatever calculator you want right now. On the final, I will make sure that either you have your own calculator or that I provide you with a calculator. I'm not going to promise you can use your iPad on the final. It's too easy to cheat. Okay. Know how? I don't even want to tell you how. But it would be easy to cheat if you had the iPad on the final. Okay, so I'm going to get you calculators. I have a whole stack of them. And I'm hoping you'll bring your own because you'll like your own more than you like mine. But I got a crap ton of them. I just have to get them here from home. So anyways, use whatever calculator you want right now. And everybody see if you can do 9 to the 3/2. I'll give you a hint. That's 9 to the power of, and don't forget to put this in parentheses. The 3/2 part, if you don't put it in parentheses, it probably won't work. Let's see what you get. Just show me your calculator. What do you think 9? I can do it in my head, and I'll show you how in a minute. But I think it's more important right now that you can use your calculator to do this. Do you even know how? I know some of you by now have heard the answer is 27, and you're not wrong, but if you can't type it in, you know, it's great that you can overhear an answer, but if you don't know how to put this into your calculator, please ask me, because if you didn't get 27, you're putting it in wrong. How many of you did get 27? Okay, good. Now let me remind you how this can be done in your head. You can be. This part here means the square root. Do you remember the square root of 9 would be 3? And this part here is the normal power. That's just to the power of 3. So this is a root, and the square root of 9 is 3, and then you put it to the power of 3. And 3 to the third is 27. That's why the answer is 27. Now, if you want to do that in your head, it's even faster than the calculator. All right, so let's do another one like that. 49 to the 3 over 2 power. You can either use your calculator or your brain, and it's okay with me if you say the answer is like 8 to the 4th. That's not the right answer, but you can tell me the answer as a power if you want. So how many of you started with the square root of 49? And what's the square root of 49? So did you know it was 7 to something? And that's the normal power. So it's 7 to the third. Raise your hand if you had 7 to the third. That's right. If you used a calculator, it would mean 7 times 7, which is 49 times 7. 49 times 7 is pretty big. It's in the hundreds. 343? Who got 343? Raise your hand if you did. A lot of people did. Good. Okay, good. I'm hopeful that you can use your calculator now. So back to this problem. We just got this answer, and it came out to 27. So am I done? No, I got to bring all this down. And it's 5 plus 2x equals 27. But from there, it should be easy. You just subtract 5, divide by something, all done. Okay, so the key here is when you get rid of powers, you use the flip of the power, and you do that to both sides. Now, one thing that I don't think we would do to you is this one technically had 2 answers. It's kind of a rough one because you have 2 answers, the positive and the negative answer. So I don't think we would get that like hardcore on your final. All right, anyways, let's move on to number 13, 14, 15. These are all about powers. So these are a classic for kids to forget. If I go a to the second to the third, this will really test if you think that I should add the 2 and the 3 or multiply the 2 and the 3. And my hint for you is just write out what a squared really means. All right, do you have a to the 6th? Raise your hand if you had a to the 6th. Okay, good. I know some of you were guessing. Here's how you could have known for sure. A squared means a times a, right? And if I do that to the third, do you get that there's probably nobody in the room would think the answer was 5? Once you look at it this way, you're going to be like, well, it's got to be 8 to the... Well, it can't be just a to the third. So a to the 5th would probably be out of the question. It is a to the 6th. I'm just trying to say, this way, you're just going to have to guess whether you multiply or whether you add them. If you look at it, a squared is like this, then it only makes sense that you got a, and a. That's what to the third means, right? A to the 6th. All right. So here's a couple other little power ones that a lot of times people have forgotten. What if you have a to the 3rd over a to the 4th? If I was on the final and I were you, I wouldn't just try to memorize that you do something to the powers and I can't remember what. I'd write this out. Would you agree that's the same as a to the 3rd? And would you agree that's the same as a to the 4th? And do you get a bunch are going to cancel now? So this really isn't that hard if you do it this way. I call this the exploded view. And then this cancels this cancels this cancels this, and then some kids go, so the answer's A? No. The answer's what? 1 over A. You can't just like act like this top doesn't exist. It's 1 over a. 1 over a and a aren't the same thing. 1 over a. Now, some kids will say, but I thought you're supposed to subtract the powers. You do, but you get a to the negative 1, and you're supposed to know that you can't leave it that way and that negative powers are unhappy. So they move down to the basement and become positive. That's how I got 1 over a. Yes, it's true. You can do 3 minus 4, but I'm afraid kids are just going to think the answer is a to the 1. 3 minus 4 is negative 1. It's a to the negative 1. And the second thing I'm afraid of is that you'll leave it that way. You can't leave it with a negative power. It's kind of like leaving me a math problem for your answer. You're supposed to know how to simplify that, and that just means the a goes down to the basement. There's your actual answer. Okay? Well, there's only one other kind that people usually mess up on, and that's like this. And if you were sitting there going, I don't know, do I multiply them? Do I add them? You could go like this. Exploded view. And most people are going to go, oh yeah, I guess I can just say that there's 8 of them. See how you can take it from being just a guess whether you should multiply them into like a more logical way to decide? That one was the kind where you add. Okay. All right. So what about that one then, Mr. Server? Well, remember me saying the negative exponents aren't happy? Got to move these w's up here where they'll be happy. There weren't any other w's to join in with, so that just becomes w to the 6th on the top. This one's also unhappy. It moves up, but there are other y's up there. These 3 y's that were unhappy, y, they join in with these other y's that are happy, and now they'll all be happy on the top, so that's going to be a y to the 6th on the top. So I'm going to rewrite my problem. Wait. I'm going to rewrite my problem now. Because there was going to be too much to be done in my head there. I got to leave you with something to do. Do you get how this and this made that? And I moved the w to the 6th up. So now it's on top. Am I done? No. But, wait a minute. Maybe I am done. No, there's some z's on the top. So there's z's on the bottom and z's on the top. So you'll have to fix this. But that's how you'd start, is by moving any negative exponents to the other side of the fraction bar. So again, 19 is not done, but you should be able to handle it from there. You can always do the exploded view thing if you want. There's 8 z's on the top, 8 z, 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 z. And then over the z's on the bottom, there's 4 z's on the bottom, z, 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 and then 4 of them cancel, and then, okay. All right. I hope that's enough coaching for you on powers. Some kids get like, but there's no fraction bar. Then do you get that's always over 1? You can always make stuff into a fraction. You just go just over 1. And now it's a fraction, and now you could move these guys down into the basement and make them happy. And then you could do exploded view. There's a whole bunch of 5s on the top, even more 5s on the bottom. Most of them cancel. Know what I mean? 5 to the 7th is like this. Okay, so how about this one? Is this the kind where you multiply or add, Mr. Server? You have to think it through. X. This is exploded view. And I know it's kind of annoying to have to write all that out, but once you do, you'll understand it better. You'll be able to figure out whether you should add it or multiply the 6 and the 3. Because you'll have to do the same thing 3 times. Okay. That's another page. And then one last page for today is this one. Let's talk about finding the slope. Everybody just write this next to that. y2 minus y1, and you're not writing, you're next to number 21a. y2 minus y1 over, what's the rest of the slope? x2 minus x1, yep. That's how you find m, which is aka, also known as the slope. And then this equation in point slope form, I bet you some of you have forgot this little helpful equation. Y minus y sub 1 equals,
Slope
yep, times,
x minus x1.
yep. We do not give that to you on the test, but it's super helpful if you have it memorized. All it is the slope formula here. It's this exact formula, except this just moved over to the other side. That's all it really is. It's a slope formula, but rearranged. All right, so how do you use this thing? This is where the point goes. If you give me a point, like you say, Mr. Server, I want this to be my point. Well, and I'm going to put the x of it here and the y of it there. And then how do I find the slope? We already talked about that. So you'd put the slope number right there. You'd have to do that separately. Find your slope from those 2 points and put it there. And then you have an equation that's all done. As soon as you put in things in those 2 red circles and then in the blue circle, you get those done. That's your equation. All right. And all right, so here we go. So we're looking at number 22. We came back from lunch. I just have 1 cheese stick left now. Dang it, why did I give that one away? And I am going to remind you how to solve these. Now, there's a fast way and then there's a slow way. But the slow way is a little easier. Everybody solve this. No, wait, it's already solved for x. Everybody put y plus 2 in there. Put y plus 2 where the x is. I'm going to pause while you try that. Okay, so we have 3y minus 2, and then instead of x, I'm putting in what it says x is. It says x is y plus 2. Do you get how that can be confusing for people? But now I've got it, so there's only a y in here, and it's just a complicated equation now. Once it's down to just one equation, you've solved a million equations by now. You've solved so many equations. I bet you can do this. Yeah, there's a lot of little steps, but I bet you can all do that. Will you be the kid who knows that this goes in there, though? That's the hard part. Can you take the one equation and put it into the other? Because you all can solve that. Now you just got to distribute the 2. And then you'll have a couple of y's. You got to combine like terms and stuff. So I want you to finish it. I mean, this is your packet. I'm helping. But. All right. Letter B. Why is substitution the best option? Well, there were 3 choices. You could have graphed it. But do you remember on graphing, you really want them solved for y? Like if you had to graph this and this, it wouldn't have been too hard because they're solved for y. Are these both solved for y? No. That's why graphing was not good. So there's another way called elimination. Do you guys remember that deal where you draw a line under it? You make all of these the opposite of what they were, and then these eliminate? Well, elimination is awesome if they're lined up like this. They're lined up straight up and down like this so that the x's are above the x's. Okay, this would have been an okay one for elimination. This would not have been good for elimination because look, they aren't even on top of each other. They aren't lined up right. So elimination wouldn't have been good, but substitution is good. I'm going to take 1 more minute for elimination. Would you go off to the side and make this equation, please? 2x plus y equals 12. And x minus y is equal to 6. Now that one on purpose, I made it good for one of the ways. Do you get this is not good for graphing? Because it doesn't have y equals. Do you get, you could substitute, but this isn't solved for x or y. So I could solve this for x or y, but that'd be a pain. So I set this one up perfectly for elimination. Do you get that these two right off the bat would just cancel each other right out? So that's the elimination way. Everybody see if you can finish it. You're adding straight down now. See if you can finish it. This is called solving a system of equations. And I know this isn't on your packet, but I also know on your test we have systems like this that you have to solve. What's 2x plus x? 3x. Common mistake. You were thinking multiply. 2x times x would be that. But 2x plus x, 3x. This and this, 0. Do I have to write plus 0? No, because plus 0 doesn't do anything. And then what's this added together? 18. Do you get, therefore, x must equal, what'd you get? 6. 18 divided by 3, 6. So that's a solving system by elimination. The other way we did was called substitution. Just going to show you quick. I'll do this, but if I had to solve this by substitution, I would have first solved this one for x. I would have added y. And do you get I'd have x equals 6 plus y, and then I'd go put that there. Right where the x was, I would put 6 plus y, and then I could solve it. Okay, so that's substitution and elimination. Those are, and then you could always graph too, but. Okay, so this one's an elimination one. You can just draw a line under it to kind of remind yourself this is the kind where you're going to just like add straight down. Okay. And then this one's graphing. And do you guys remember how to even graph? It's been a while. Everybody, please label this for yourself. That's the y-int. What do you think that stands for? Y-intercept. Good. And that 2 right there, what is it? Slope. And I'm going to put it over 1. What? You need to put a 2 over a 1. Because then I got the what and the what. Very good. This one's rise, and the bottom one's run. So I would start at -5, which is like down here. And then I would rise 2 and run 1. Rise 2, run 1. Just kind of like that. You always start at the y-intercept, and then you rise and run. Up and over, up and over, up and over. Yes?
How do you know which way to run?
Always run to the right. That's easy. Always run to the right. Period. The only question is if there's ever a negative rise, do you get that'll be down? But you always go to the right. It's either up and to the right or down and to the right. Okay, so you always run to the right. But if there's a negative number, you're going to fall and run instead of rise and run. All right, and then what if they want you to do less than? You shade to the left. Maybe you should write that for a note for yourself. Left. If it's less than, you're going to go shade left. If it's equal to, you have a solid line. This one, it doesn't have an equal to. So this will be a dotted line. And if it's greater than, those shade right. To the right. Okay? Okay. I feel like that is as much as your brain is realistically going to hold for today. So there's now you and there's later you. Now you would probably rather just whip out your cell phone and just hang out and relax, spend a long day. Later you is going to really wish you had done some of this packet so that you don't get later you doesn't get stuck with doing the whole packet the night before the final, you know? So it'd be wise for you to get as much done as you can during the hour. During the last 10 minutes of class, I do allow cell phones to come out as long as you are working at the same time, but emphasis on the doing some work. And then if you get stuck, bring it up. I'll happily walk you through. I can walk you through lots of problems. As long as you paid attention to this part, which you all did, then if you have a one-on-one question later at the end, I'll help you. That's all I got for the video for today.